Hi, welcome to our very last lecture focusing on science. So we started out with language and then we looked at the impact of culture on the teaching and the learning of science. And now we are taking a look at what is the best pedagogy that we can use with English language learners when we're teaching science. So I actually have 10 tips for you today. I'm going to start out with a little bit of an overview that kind of especially reaches back to what we talked about with culture. And then I've got 10 tips for you. So there's a handout that goes with the lecture. You don't have to have it printed out, but it will be easier if you have it to refer to as I'm talking, just to kind of make sense of some of the things that I'm saying. And a lot of the ideas that I am sharing today actually come from a university in North Carolina that's been partnering with school districts in the area. If that interests you, I didn't put the article up because there's actually a lot that I've posted in our module. But if this interests you and you'd like a copy of it, especially so that you can work with other teachers yourself in the future, just let me know and I'll go ahead and post that. But anyways, it's a great resource. So the place that I want to begin in talking about the best possible pedagogy for English language learners in science is to talk about the fact that science, time for science, whether that's all you teach physics and chemistry in high school, or you spend 4 hours a week with your fifth graders on science, whatever it is a time for talk. And I think especially if you think back to what we looked at last week, when we looked at how cultural interpretation can really change what a student's expectations are and their assumptions are and their ideas are when they walk into your science class, it kind of helps us understand why there needs to be so much talk. So for example, I think that we often, if we don't think about it too much, we consider science as kind of this set thing. There are these ideas, and our job as students is to learn those ideas, take them in, memorize them, and then regurgitate them, whether it's on a test or whether it's as science teachers ourselves. But I'm kind of hopeful that last week when we looked at kind of a different way of approaching science, a way of understanding that it's messy, that it's really just the formation of ideas with the best information that we have, which is directly connected to our starting ideas, which are sometimes connected to our background culture and sometimes connected to our real lived experiences in this world. Science is messy. Science is creative. Science is tentative. It's full of tentative ideas. And anything, if we look back in the 1950s, things that we were absolutely sure about, half of them we found new ideas to supplant those in science. So no matter how much we try to believe that science is just these hard facts that we simply need to memorize, the truth is that it's a living, breathing way of making sense of the world. There's lots of reasons to doubt the ideas in science. There's dilemmas that we face in science. Sorry, I have hot tea there, and I can see the steam coming up from it. And so I think that especially if you are readying yourself to be especially effective with your English language learners in science, then I think your classroom talk in science time has to be the principal thing that's happening. Lots and lots of rich talk about what our starting ideas are and what our questions are and what we're wondering about and what would it take to convince us that one idea should supplant our previous idea, that kind of thing. So your classroom needs to be full of talk for any science learning, the most effective science learning, but I would argue, especially for those classrooms that have English language learners, and thus any diversity at all. And so there's a connected idea to that, and that is that the science textbooks that we use don't tell the whole story of science. They can't, right? I mean, they have to pick and choose which people they focus on, which innovations they focus on, how they tell that story, what they leave out. If you have one paragraph to devote to an innovation, things are going to get left out, right? Which leads me to people are going to get left out. I think that for a lot of students, when they are, for me, for example, when I was growing up as a female in a poor family in a rural area, and no one around me except for our town doctor and the teachers had any further education, talk of science and scientific innovations, it didn't seem relevant to me at all. It certainly wasn't, young females that were showing up in that story about how anything was innovated, how something was discovered. And yet, that was often the case. It was often those with less access to resources who were discovering things, but they're not the ones who show up in the textbook. It was often people of color. It was often people around the world who were discovering things, people whose first language was not English, and yet they very rarely show up in those textbooks. So I'm going to challenge you as a teacher of science. Before you start a new unit with your students, look out at who your students are and see if you can't do a little bit of sleuthing on your own to figure out how some of those backgrounds in front of you and your students actually connect to the unit, actually connect to possibly even the innovations that are being celebrated, the theories that are being celebrated as at that moment as correct. Just a couple of examples that I found, because International Women's Day was just recently, there were a lot of articles looking at, and especially with the recent film Hidden Figures, there were a lot of articles taking a look at how women were often behind innovations, but then left out of the story. And this is equally true for anyone around the world, anyone with any cultural diversity at all, other than just mainstream U.S. Culture. And so a couple of examples, they're on the handout, that I just wanted to highlight, but there's so many more. I just chose a couple. In 1888, a woman developed a clothes wringer. So this is the old-fashioned thing where you would go like this and it would wring the water out of your clothes, which probably sounds like no big deal in this day of clothes dryers, but that could cut days off of drying clothes. So it was a big deal for a lot of people. It was invented by an African American woman, but she sold the idea to an agent, and her reason, and then that agent, of course, made lots and lots of money. She just made $18. But the reason that she did so was that she thought that if people knew that an African American woman had come up with this idea, no one would buy the product. And another example, in 1905, a female scientist, Nettie Stevens, discovered that gender is determined by chromosomes. Up until that time, it was thought that it was determined somehow by environment. And so she discovered this, she published the paper. Later that year, a male scientist, E.B. Wilson, discovered the same. He published as well. So now you've got two papers coming out. One actually comes out before the other, but the scientific community takes up his discovery as the one that they point to as the moment when we took that step forward in our understanding. So those are two of many, many examples, and I didn't even look hard to find some more multicultural kind of examples. So One way to enrich the talk that happens in your classroom around science is to find ways that your students' own backgrounds and experiences and heritages, how they connect with the unit that you're taking a look at. And your textbook is not going to tell that story. I hope that that's not true in 20 years, but right now that is the case. So if you're going to connect your students that way, you're going to have to put the work in. And I encourage you to do that. So let's continue on with this idea of talk. And actually my first tip to you comes straight out of findings around what works best for English language learners. And actually, this is one of those tips that spreads across to everybody, all students. And that is, when you're introducing a scientific concept, introduce it in Bix language. And as students are starting to talk about it, think about it, that kind of thing, let them use Bix language. Let them use that everyday, colloquial, informal language to try to explain it and figure it out. And then over time, start to add that CALP language. And I found a really great example. It's from that article I mentioned from the North Carolina University. And they actually call this interlanguage, letting students start out with Bix and then slowly move into CALP. They call it its own kind of interlanguage, which I like. So here's an example. So the student might say, we put the smooth powder in the bag along with the crunchy powder, and the bag blew up and got hot. And then the teacher might recast that or prompt by adding in more CALP eventually. We mixed baking soda and calcium chloride with water, resulting in a gas, and heat was released. So now you can see the vocabulary changing. And then just to kind of show of where the target would be eventually when students are doing upper level high school science work and college level science work. So a scientist would say, the combination of baking soda and calcium chloride is an exothermic reaction with the products of sodium chloride, calcium carbonate, and carbon dioxide. So you can see why your second graders might not say it that way. But anyways, I think that that's a really nice example, a concrete example of the way that our language can change and the way that you as the teacher can slowly model and bring in those more scientific ways of saying things. Okay, more of that Bix. And then the second tip that I have for you, because you want your classroom, you want that talk to be really structured and scaffolded for the English language learners so that they can actually participate. Because if you think about it, if you have beginners, if you have intermediates in your classroom, they're going to struggle not to do the scientific experiment necessarily, but to express what they learned. And so you want to make sure that you provide them with sentence frames. What are sentence frames again? Sentence frames are the beginnings of sentences or kind of the skeletal parts of a sentence that students can use over and over and over again. So, for example, you could create sentence frames around wondering. We want our students to be lots of talk about what it is they wonder about. So what could a sentence frame about wondering be? Stop and think for a moment. It could be something like, I wonder if blank will, right? I wonder if blank will blank. You want them with sentence frames around predicting. I predict that blank. Concluding, I think that blank happened. You want them to have lots of ways to ask questions, lots of sentence frames around there, lots of sentence frames around what they're observing or what they did observe. And I've actually got 2 links waiting for you in the modules of really rich examples of sentence frames you can use with your students in science. One of them, that's what the entire link is. The other one is part of a bigger paper, and it's all contained in one table. You'll see the pages there. But they really assist your students. They truly are a scaffold. Because if you think about it, if a student observes something and now they want to put it into words, or you're asking them to put it into words, they're struggling with a couple of things. They're struggling with the idea, the actual science that they're learning, the actual science that they saw. And they're also grappling with just the basic way to say it in English. If you provide sentence frames, you're taking care of one of the problems for them. Now they can concentrate on what really matters, which is those ideas that they are gaining or that they are forming in science. So sentence frames are the way to go, and yes, you can extrapolate and use them across the curriculum, but right now we happen to be really emphasizing them with science. Okay, so we've talked about lots of rich talk, encouraging students to see their own connections, their own cultural heritage connections, for example, with scientific discoveries, starting out with BICS, slowly moving into CALP, using sentence frames. Those are very, very important. Another thing that comes out that seems to work really well with English language learners is to adopt the teaching strategy where you use text cards. What might a text card be? Maybe it's a stack of cards with individual vocabulary words that all relate to the unit that you're in right now. Or maybe it's a series, it's a little bit bigger or smaller font cards that have statements that are either true or false. Or maybe it is, if you're learning in biology, how classifications are done, how the classifications of mammals, for example, work, then it would be different examples of those different levels of hierarchy. So what would you use them for? They are a way for students hands-on to get their hands on materials, and even though they're verbal materials, they can do something with it. You could have them, for example, if there were statements, you could have them sort them into two categories. The statements they think are true, the statements they think are false. You could have them sort the statements around what they agree with, what they disagree with. You could, if you were teaching a biological process, like for example photosynthesis, you could have them place the different cards in terms of the kind of the chronological stages of the process. And you could also do matching. So for example, maybe in chemistry you're learning about different minerals and then what is made from those minerals. And so you could hand a stack of cards to each group or to each pair, and they are matching them up in terms of what the mineral is and what's the thing that we get from that mineral, that kind of thing. So it's a great way to take that learning. It's hands-on, but it is verbal, and it gives them another rich experience around those concepts that they're learning. And especially the agree, disagree, true, false cards, it gives students a little bit of agency to kind of express what it is that they think is true, which I think is really important. We need to make as much space for students in science as possible. Another thing that comes up again and again in supporting English language learners with science is having word walls that are truly active. So you are adding to them every day, you are using them, you're encouraging students to use them, you're pointing at them. Even they're staying up during tests, you're encouraging students to use them as a resource, for example. And one thing I'd like to encourage you to do, I think that probably what we're all thinking of right now is word walls in science are, as in your chapters you're learning things like enzyme and catalyst, those things are going up. I'd like you to think about word walls that are more universal around the kind of science that you're carrying out. For example, procedure words. For your native speakers of English, explaining that they put something into something, they poured something, they watched, they whatever, not difficult at all, but those vocabulary may be missing for your English language learners. So what about a word wall in which you're constantly adding new procedure words, like basically verbs? What about opposites? When we ask students to describe something, what do they observe? We're really often asking them to use opposites: hard, soft, dark, light, light, heavy, that kind of thing. So what about a word wall of opposites, or a word wall about movement, how quickly something moved, or how it moved, that kind of thing. I think you get what I'm saying. Yay, word walls, but not just with those new words that are just being introduced in this unit. What about the long-term words you just need to just operate in the science classroom? Think about that. One thing that's been found occasionally to work for English language learners is to support vocabulary learning with games. So what kinds of things, for example? It could be a bingo game. So maybe you've been learning about the different parts of a plant, and all the students have a bingo card, and it's got images on it, and you call out a part of the plant, and they have to identify that kind of thing. You could also use charades with certain kinds of science processes. You could do 20 questions, what is it? And so the class is asking questions. You could play odd one out, in which students see 3 or 4 things, and one of them doesn't belong. It's in the wrong category, it's in the wrong hierarchy, it's not part of that process, that kind of thing. And so they have to call that out. So think about being creative in your science classroom. Think about the role that games could play in helping your students make sense of all this. Another one is to make sure that you teach word parts. So this might sound like a language arts kind of activity, doesn't matter. If you think about it for your English language learners, every class is language arts, right? So make sure that when you introduce the word photosynthesis, that you're talking about what does photo mean, and teach that word part, help them understand, show them other words that relate to photosynthesis that use that prefix, for example. It's going to help them start to make sense of the vocabulary. It's going to help them remember it, because now they have one more way to anchor the meaning of that word rather than just straight memorization. But really importantly, when they encounter next year, when you're not their teacher anymore, or on the test, when you can't help them, when they encounter a word that begins with photo, they have something to use to decode it, and they will be more likely to be able to guess the meaning of the word from context, that is a powerful skill for English language learners. No matter how fast they're learning vocabulary, they will always be encountering vocabulary far, far into their educational experience that they don't know. And their best tool is to be able to guess reliably. So, teach those word parts. And number seven, explicitly teach those multiple meanings of words. So in science, there are some words, not as many as in math. We really emphasize that in math. So it's not like that, but there are words in science that when students walk into class, if they've been exposed to a lot of BICs, they already will have an anchored meaning for this word. But in science, it means something a little bit different. Like maybe in language arts, all year they've been writing reflections. But now in physics, they encounter the word reflection and it seems to have a different meaning. Don't put your English language learners in the situation where they have to guess, whether they're guessing that there's some different meaning being applied here. Explicitly teach it. Before you put that new unit in front of your students, before they encounter the textbook, look ahead, look for any words, new vocabulary words they're going to encounter that might already be anchored with a BIC's meaning. The way I handle such things, I'm a big T-chart fan, you know, the chart like this. So well, more like this. And so on one side, you know, the word Bix, the other side CALP, or whatever you want to call it, whatever works with your students, you know, every day and school, meaning, whatever. And then list those and make sure that the students have a good grasp. You might even have them hold on to that as kind of a reading scaffold as they're reading their chapter. Okay, so make sure to do that. Another thing that shows up is the power of graphic organizers in science. So if you think about it, we've already talked about in science, students are going to encounter more new vocabulary on every text page, more new vocabulary in every unit that you cover with them than in any other discipline. And so another way that you can give them traction with that is to come up with graphic organizers that match up with the content that you're teaching. Whether that's like a process chart, like a flow chart, and you've got ideas connected, like maybe you're teaching a process, or maybe it is the different qualities of different minerals. So maybe what that looks like is like a mind map. So in the middle, you've got the name of a mineral, and then you've got maybe 5 or 6 little spokes coming off, and then you've got descriptions around them. But don't just throw out any graphic organizer. Think about the one that matches up with the content that you're teaching and that will help them have yet another experience with the vocabulary that they'll be able to make sense of it. Okay. And completely related is, because of that new vocabulary learning, make sure that students encounter new vocabulary words in many, many contexts. Use them as often as possible. So, for example, you might, if you've got different groupings of tables and you have the ability to hang something from the ceiling, you might, every week, even though groups may stay the same, the name of their group may change, and this may be some of the vocabulary words that are coming up that week. And so you would say, okay, in the catalyst group, what I want you to do, and then say, by the way, what's catalyst again? And then see if you can elicit student voice on what catalyst means. And if they need some support, you can help them with that. But just making sure they encounter the words as much as possible, and even bringing them whenever possible into your everyday talk with the students. And one thing that you can do to kind of give them a different experience with words is think about, are there some visuals that you could bring in, whether you're putting them up around the room, or you're making them available at the front of the classroom, or every student's getting a copy, that kind of thing. Think about how you might use visuals to support that vocabulary learning as well. One thing that you'll find in the modules that I've placed for you is the Visual Dictionary of Science. And actually, there's lots of tools like this. So there's the Visual Dictionary of Chemistry, the Visual Dictionary of, and so I've just kind of chosen a generic one for you to take a look at. Some of them, if you get them used, you can get them for $2 or $3 on Amazon. So something to think about, a reasonable tool you could have ready in your classroom. But just one thing to think about is supporting with visuals. And while we're on visuals, it's also important that you take a look ahead at the visuals that are in your science textbook and make sure that your students, your English language learners, know how to decode them and see how they relate to the words on the page. So to support us kind of thinking through this together, let's see if I can find it. In your handout, I've actually got 3 screenshots. They look like this. And I took them from an interesting article that was written, I think it's from New Zealand, I've forgotten. And if anyone's interested in this one as well, I'll be glad to post it, but I just didn't want to overwhelm you with the less important stuff. And so it was looking at what kinds of relationships are there in science textbooks between words and images, and how do students respond to that? Now, one of the reasons I didn't post this in your unit is because they were not looking at English language learners. They were really mostly focusing on native speakers. But it does get us thinking about that word and picture relationship. So those 3 examples I have, what they found is that there are textbooks in which prose is primary. What does prose mean? Prose means the words. What does primary mean? It's the most important. And so in those words, the writer wrote the textbook, and then after the first draft, someone who was in charge of images created or chose images to match up with very specific parts of the text. And so you can, although the image may not say exactly what's in the text, it may give additional information, for example, there is a direct connection. And you could cover up the images and still get most of the information from the text. So that's prose primary. And what they found in their study was that textbooks in the US are mostly prose primary. So anyway, so something to think about, just have in the back of your mind. What does it mean exactly? Not sure. But I think it's important for you to be thinking about that relationship. So very quickly, the other 2, less important for us right now in the US in textbooks, but what they're finding is that there's a movement towards focusing more on the visuals. So prose subsumed, and prose, again, of course, means words, means that there's more of a 50-50 relationship. In prose subsumed, if you were to cover up the images, you might be missing not 50% of the information, but maybe 30%, that kind of thing. So images matter more. And then for fully integrated, if you look at that example, it looks like the kinds of books that we associate with like DK, their visual explanation of castles, visual exploration of how a car works, that kind of thing, in which most of the page is taken up with a visual. So in these kinds of examples, and the study didn't say that that they had found it in the U.S., but in this kind of text, you would actually have to be sure that you knew how to decode the images. And what do I mean by that? Well, we in the U.S., most of us are native speakers of English. That's changing, but right now most of us are native speakers of English, and the assumption is that we're approaching reading from an English standpoint. And so if we, for example, in an image, if we're showing development of something, let's see if I can get this right, we start on, I'm going to start the opposite for me so it makes sense to you. We start on the right and move to the left. There's this assumption of that's how the process works, and we assume that is, even if there's no arrows, that the movement is that way. If you learn to read in Arabic, for example, that's not going to be how you assume the movement works across the page. You might actually read it the opposite way. So something to think about before you put that textbook in front of students, and especially if you're part of a team choosing a new science textbook, to really take a look at how those images work. Remember that what we assume assists native speakers of English may not be an automatic assistance to English language learners. So sometimes images take just as much work on the teacher's part to scaffold as the words. So something to think about. So I hope that was helpful. Those are from my reading of the literature, from my kind of scouring of the best pedagogy out there for English language learners in science. That's what I see. So you've got a very brief science chapter to read in your textbook, and then a lot of links that I hope help you kind of make sense of all of this and see it in action. Okay, see you online in our discussion.